Hello everyone. Today I am here with you all with 13th chapter of class 9th maths curriculum, that is surface area and volume. In our previous classes we have learnt about plane figures like your square, rectangle, triangle, circle. All these are two-dimensional figures which are having your length and width and which can easily be drawn in the notebook or on the board. We have even learned how to find the perimeter and area of all these figures. Whenever we are considering the plane figure, we are using the term area. Now, in this chapter, we will be learning about solid figures. That means figures which are having three dimension. Along with the length and width, they are having height also. So, such type of figures are known as your solid figures, which are having your three dimension, and the term which we use for these figures is your surface area instead of area. Whenever we are talking about solid figures, we are using the term surface area. So in this video, we will be learning how to find the surface area and your volume of the solid figures like your cuboid is there, cube, cylinder, cone, and your sphere. We will be learning about all these. So let's start with the cuboid. So how the shape of the cuboid looks like? It is like this. If this is one of the box we have taken, this is another. So this shape is your cuboidal shape, in which this is the length, this is the width, and this is the height. If length is denoted by L, width is denoted by B, and height is denoted by H, so this is the shape which looks like your cuboid. In our day-to-day life, we come across so many cuboidal shapes, like brick is there, like our book is there. All these are examples of your cuboid, which are having different length, width, and your height. Now, if we are going to see the cuboid, it is having 6 faces. We can take an example, like this box is even an example of your cuboid. This is the length of the cuboid, this is the width of the cuboid, and this is the height of the cuboid. So we can see over here that a cuboid is having 6 faces. One, bottommost, second is uppermost, this third face, fourth face, fifth face, and sixth face. So a cuboid is having your 6 faces it is having, and it is having 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices it is having, and it is having your 12 edges. 12 edges, 8 vertices, and 6 faces it is having. We can see over here that all these 6 faces are rectangular in shape. So if we want to cover this box, then whatsoever the area will be required, whatsoever the paper area of the paper will be required, that will be the surface area, and we say it to be your total surface area of the cuboid. Now if we will see that this is your L, this is your B, and this is your H. So area of this face will be your L into B. Area of this face, uppermost face, it will be L into B. Similarly, area of this face will even be your L into B. So area of the uppermost and the bottommost face will be your L into B. So L into B over here, L into B over here. So it will be your 2 times of L into B. Now if we will consider this face, so this is your L and this is your H. So area of this face will be L into H, and area of this face will even be your L into H. So area of these two faces, this one and this one, front and the back, it will be your L into H. So 2 times it will be, so 2 times of L into H. Now if we will take this face, so this is your B and this is your H. So area of this face will be your B into H. Similarly, area of this face will even be your B into H. So area of these two faces will be 2 times of your B into H. This is the total surface area of the cuboid. So total surface area could even be denoted by your TSA. Total surface area of cuboid will be, over here what we can do is 2 could be taken common. So 2 into LB plus LH plus BH. This will be the area, total surface area of the cuboid. But whenever we have to ignore the topmost and the bottommost surfaces, and we have only to consider only the 4 sides, in that case the surface area is known as your lateral surface area. We are just ignoring, we are just removing your topmost and the bottommost surfaces, and we are only taking these 4 surfaces, then the area which will be getting will be of the 4 faces, and that will be your, we won't be taking your 2 into L into B. This part we are not taking. This uppermost and this bottommost portion we are not taking this, and the area of this was your L into B, L into B of this portion, L into B of this portion. So we are not taking your 2 into L into B for finding your lateral surface area. So remaining area will be 2 into LH plus 2 into BH. This will be the lateral surface area. Over here 2H could be taken common and it will be your L plus B. So if we are only considering the topmost and bottommost surfaces, we are not considering. When we are not considering these two faces, then the area which we will be getting will be the lateral surface area, which will be given by your 2 into H L plus B. And if we are considering all the 6 faces, then it will be your total surface area, or the surface area even we can say, then it will be your 2 into LB plus LH plus BH. This will be the total surface area and this will be the lateral surface area. Now, if instead of cuboid, we will be considering the cube. We know that if all the 3 faces, your length, width and height, all the 3 dimensions are equal, then we say it to be a cube. If all the 3 dimensions are same, if it is your A, length is A, width is even A, and height is even A, then we say this shape to be a cube. It will be a cube, and if these 3 dimensions are different, then it becomes your cuboid. Now, what will be the total surface area of a cube and what will be the lateral surface area of the cube? So we can see over here that this shape is almost equivalent to your cube, means length, width and height almost equal. So again we can say that it is having your 6 faces, 1 2 3 4 5 6, topmost, bottommost, front, back and the side ones. So it is having total 6 faces it is having, and your length is even A, width is even A and your height is even A. So all the faces, area of all the faces will be your A into A, that is A square will be the area of all the faces, and it is having your 6 faces. So total surface area will be 6 multiplied by A square, or you can say 6 multiplied by side square. Whatsoever is your length, whatsoever is your, the same will be your width also, the same will be your height also. So if your length, width and height which is equivalent to A, so it can be written as your 6A square. Otherwise, in general, we can write it as 6 multiplied by your side square, whatsoever is the side of the cube. Now, if we will be ignoring the topmost and the bottommost faces, if we will be not taking, we were not considering the top face and the bottommost face, then we will be considering only these 4 faces, and in that case, we will be getting your lateral surface area. Lateral surface area will be your, we are not taking 2 faces, we are only taking the 4 faces. So it will be your 4 multiplied by your A square, where A is the side of your cube. All the 3 sides will be equal and A will be the side of the cube. In that case, lateral surface area will be on 4A square. So how we are getting it basically, suppose we are talking about a cuboid. So we have taken a rectangle whose length is L and whose width is B. And so many these type of rectangles we have taken. Suppose a sheet only we have taken and we have kept one over the other. Like we see our book. What happens is, if we consider our book, see, this is our book, this is the length of the book and this is the width of the book. We have kept so many pages which are having the same length and same width, and we have kept one over the other. So this much of height it got. So that's the reason it became a cuboid. So whenever we are compiling, we are just stacking one over the other. So many rectangles, we are getting the shape which is your cuboid. And similarly, we can see over here, if we are taking squares as the base, whose length is even A and whose width is even A, and we are keeping one square over the other with the same side, in that case up to this much of height only, whatsoever is your length and width, up to that height only, it will be keeping one over the other, all the squares, then it will attain the shape of your cube. So till now it is clear that cuboid total surface area, when we are considering all the 6 faces, your total surface area will be 2 into LB plus LH plus BH. And if we are removing your topmost and the bottommost faces, then we will be considering only four faces, and the area of that will be your lateral surface area, that will be given by 2 into HL plus B. Similarly, if we will be taking cube, it is a special case of your cuboid only, where L is equivalent to B is equivalent to your H. Suppose it is your A. So when we are considering all the 6 faces, it will be your total surface area, that will be 6 into A square if A is the side. And lateral surface area, when we are not considering the topmost and the bottommost face, in that case your area of 4 faces will be your lateral surface area, that will be your 4A square. Now suppose we have to tile your room. Tiling is to be done in the room. So what we will be doing is, tiling will be done over here only, on this face only tiling will be done. So we will be finding the area of this tile, this portion. That means L into B we will be doing. And whatsoever will be the size of the tile, the area of that tile even we will be finding. And the number of tiles will be given by, if we have to find the number of tiles required. So what the number of tiles will be? It will be the area where tiling is to be done. Where tiling is to be done, where we have to tile. Tiling is to be done divided by area of a tile. Area of a tile. If we will be dividing these two, we will be getting number of tiles required. Right? So whatsoever is required, accordingly we'll be considering. It is even possible we have to make a box in which we need not to cover it. Only 5 faces we will be considering. In that case, we will be ignoring this topmost face and we will be considering the bottom over here we will be considering. So we will be removing only L into B only, one L into B, but we will be considering rest all 5 faces of it. So what is required in the question, accordingly we will be selecting that what area is to be considered. Now let's see some of the questions from your exercise, your 13.1. Say first question we are considering. Question number 1. A plastic box 1.5 meter long. Length is your 1.5 meter. 1.25 meter wide. B is your 1.25 meter. And 65 meter deep. 65 meter deep means your height only. Height is your 65 centimeter it is to be made. Now it is opened at the top. Means your topmost face is not there. Only 5 faces we have to consider because it is open from the top. Ignoring the thickness of the plastic sheet, determine the area of the sheet required for making the box. First part we are considering first. Area is required, first part. What will be the area which is required? So area is required of 5 faces. We are not considering this top face. We are simply considering the 5 faces. 5 faces means your lateral surface area, all the 4 faces, all the 4 boundaries we will be considering. So we will be considering this lateral surface area, that is 2 into H, L plus B. And the bottom face even we need to consider. And the area of the bottom face will be your L into B plus L into B. This is your required area. This is your required area. So it will be 2 into H. It is in centimeter. So we will convert either it in meter or we will convert all these in centimeter. So we are converting this into meter. So 65 centimeter will be your 0.65 meter. So it is 0.65. L is your 1.5 plus B is your 1.25 plus L into B. L is your 1.5 multiplied by 1.25. This will be the required area. This is the area of 4 faces and this is the area of your bottommost face. Uppermost face, topmost face is not available. So 2 into 1.65 will be your 1.3. 1.3 and this will be your 5, 6, 7, 2.75 plus 1.5 into 1.25. This will give us 1.3 into 2.75 is your 3.575 and 1.5 into 1.25 will be your 1.875. This will be your 550 carry over 1, 14, 15, 5 carry over 1, 14, 4 carry over 1, 3, 4, 5.45 meter square. This is the required area. Now what is asked? Second part is your the cost of the sheet for it. If a sheet measuring 1 meter square, cost of 1 meter square is your 20 rupees. Cost of 1 meter of sheet is your 20 rupees. So what will be the cost of your 5.450 meter square? So what we will be doing is we will be multiplying 5.450 multiplied by 20. So cost will be, second part, cost will be your area multiplied by rate. That will give you 5.45 multiplied by your 20. That will be 0. I am taking here 5 2s are 10, carry over 1, 4 to 8 and 9, and 5 to 10. 109 rupees. So cost will be your 109 rupees. So this is how you have to decide first that which area is required. Accordingly, you will be making the formula, and then for finding the cost, you will be multiplying the area by the rate. Now let's see the question number 7. Shanti's sweet stall was placing an order for making cardboard boxes for packing their sweets. Two sizes of boxes were required. The bigger dimensions are one of the dimension is your 25 centimeter by 20 centimeter by 5 centimeter. And another dimension is your 15 centimeter by 12 centimeter by your 5 centimeter. These are the dimension of the boxes. For all the overlaps, 5% of the total surface area is required extra. For overlaps, 5% extra is required. If the cost of the cardboard is rupees 4 for 1000 centimeter square, cost is rupees 4 for 1000 centimeter square. Find the cost of cardboard required for supplying 250 boxes of each kind. 250 boxes of each kind. This is the question. So first of all, what we need to do is we have to find the total surface area for this box, total surface area for this box. One box we will be finding it out. Then we will be multiplying it by 250 because 250 boxes of each type is required. So total surface area, we know that the total surface area is your question number 7. It is total surface area will be 2 into LB plus BH plus LH. This is the total surface area. So total surface area, first of all, 2 multiplied by 25 into 20 plus 25 into 5, 25 into 5 plus 20 into 5. This will be the total surface area. This will be 2 multiplied by 25 into 20 will be 500. 25 into 5 will be 125 and it will be your 100. That will give us 500, 600, 725, or we can say 5 2s are 10, 2 to 4 and 1 5, 7 to 14. 1450 unit was your centimeter, so centimeter square. This is the total surface area of bigger boxes. Now we will be finding the total surface area for the smaller box. So that will be again 2 into LB plus BH plus LH. That will give us 2 multiplied by 15 into 12 plus 15 into 5 plus 12 into 5. This will be the total surface area of the smaller box. That will give us 2 multiplied by 15 into 12 will be 180. 15 5 is 75. 12 5 is 60. So it will be 2 multiplied by, it is your 5, 7, 14, 21, 1, 2 and 1, 3. That is your 2, 5, 10, 1, 3, 2, 630 centimeter square. This is the total surface area of the smaller box. So total surface area of both the boxes will be your, total will be of both the boxes. That will be 1450 plus 630. That will give us 0, 5, 6, 7, 8, 6, 4, 10 and 2080 centimeter square will be the total surface area of one box of bigger dimension and one box of your smaller dimension. Now both the boxes are required your 250. So we will be multiplying it by 250 for 250 boxes. This is for one box of bigger dimension also and for smaller dimension also. And now 5% extra we have to take. because of overlaps. Whatsoever the overlap will be done, we will be taking 5% extra. So 5% extra means if we are taking x is the area, 5% extra means we will be taking 5% of this. So 5 multiplied by x over 100. This will be the 5% extra. So we can say x plus, it will be your 0.05x, or we can say 1.05x, right? So similarly, what we will be doing is whatsoever the area will come, we will multiply it by 1.05. 5% extra means in 100 you are adding 5% more. So if it was 1, so it will be 1 plus 5 upon 100, that will give you your 1.05. 1.05. So we will be multiplying whatsoever the total area will come, we will multiply it by 1.05 for 5% extra overlaps. So total required area will be 2080 multiplied by 250 we are doing, because we want 250 boxes of each kind, and because 5% extra we have to take for overlaps, so we will be multiplying it by 1.05 instead of 1. If no extra is there, so it will be 1. Now 5% extra is there, so 1.05 we will be taking, and if we will multiply all this, it will be your 546,000, that much of centimeter square cardboard will be required. This much is the area of the cardboard required. Now see, the cost is your rupees 4 for 1000 centimeter square. For 1000 centimeter square, cost is your 4 rupees. For 1000 centimeter square, cost is your 4 rupees. So for 1 centimeter square, cost will be 4 divided by 1000, and for this much of centimeter square it will be multiplied by 546,000. These three zeros are going to cancel, and it will be in rupees now. 6 4 is 24, 2 4 4 16, 7 18, 8 carry over 1, 4 5 is 20, 21. Rupees 2184 will be the total amount which is to be paid, or which is required for your making this much of your cardboards, this much of boxes. For your bigger one also, for a smaller one also, total your 250 quantity we will be considering. So this is how we can find, using these formulas we can solve the questions. Now let's see how to find the surface area of a cylinder. This is how a cylinder looks like, whose base is your circle, and if we are keeping the circle of the same radius one over the other up to some height, then we are getting the shape of a cylinder. As we were saying in the case of your cuboid, that if we are taking the rectangles of the same size and we are keeping it one over the other up to some height, then we are getting a shape of a cuboid. The all faces of a cuboid were your flat faces, but over here we can see that a cylinder is having two flat faces. This is topmost face, which is circular, which is flat, the bottommost face, which is even circular, which is flat, and this is your curved face. So a cylinder is having three faces, two your flat faces and one is your curved face. And if we are keeping the circles at right angle to the base, then we will be getting a right circular cylinder. But if we are not keeping the circles at right angle to the base, then it will not be a right circular cylinder. Or if your base is not circular, in that case also it will not be a right circular cylinder. So in this chapter we will be dealing with your right circular cylinder only. So let's see how to find the curved surface area and your total surface area of the cylinder. See, if we are going to take a rectangular page, this is a rectangular page, right? And if its height, this is the length of the rectangle and this is the width of the rectangle. If this width of the rectangle is equivalent to height of this cylinder, and the length of this rectangle is equivalent to the circumference of this circle, the circle which is at the top and the bottom, this circle, this is the circumference of the circle. If the length of this paper is equivalent to the circumference of the circle and the width of the paper is equivalent to height of this cylinder, then we can get the curved surface area of your cylinder. So what the curved surface area of the cylinder will be? This is a page which we have taken, a rectangular page we have taken, whose this is the length and this is the width of this rectangular page. This width is equivalent to your height of this cylinder. So this is suppose your h, and this length is equivalent to circumference of this circle. The base is your circle, so circumference of the circle, so this could even be written as your 2 pi r, where r is the radius of your circle. This base is the circle and the radius of this circle is denoted by your r. So the area of your rectangle, we know it is your L into B, so it could be written as your area of rectangle is L into B, where L is height of the cylinder, which is denoted by h, and this length is your circumference of the circle of this circle, that will be your 2 pi r. So we can say curved surface area of cylinder will be 2 pi r h, where h is the height of the cylinder, h is height of cylinder, and r is radius of base of cylinder, because base of the cylinder is your circular, so radius of the base of the cylinder is your r, and h is the height of the cylinder. This will give you 2 pi r h, will give you the curved surface area. Now the topmost and the bottommost faces are your circles, and we know that the area of a circle is your pi r square. Now two circles are here, so total area will be of the top even and the bottom will be your 2 pi r square. So the total surface area of cylinder will be your 2 pi r h plus 2 pi r square. This is the curved surface area. This is the area of the top and the bottommost faces, which are circular. So the total surface area, which will include the top even, bottom even, and the curved surface even, that will be your 2 pi r, could be taken common in the bracket r plus h. So this is how we can find the total surface area of a cylinder, and this will be the curved surface area of the cylinder. So according to the question, we will be finalizing that whether curved surface area is required or your total surface area is required. It is even possible that bottle is there without lid. In that case, we will be taking curved surface area, and only single pi r square we will be taking for the bottommost face. Topmost face we will be ignoring because your lid is not there. So according to the question, we have to finalize that what area is required. Now let's see some of the questions from your exercise 13.2. Question number 1 we are considering. Question number 1. The curved surface area of a right circular cylinder of height is given to us as 14 centimeter, and curved surface area is given to us as 88 centimeter square. Find the diameter of the base of the cylinder. We want the diameter of the base of the cylinder. Now we know that the base of the cylinder is your circular, so curved surface area is given by your 2 pi RH. This is the formula for finding curved surface area. So 2 pi RH is equivalent to your curved surface area of cylinder. Now value we will be keeping 2. Pi is your 22 by 7. Until unless it is mentioned that use pi is equivalent to 3.14, we will be using it as 22 by 7. Value of R we need to find it out. H is your 14. It is equivalent to curved surface area, that is your 88. Now see over here, 7, 2 times it is 14, and it is 2 multiplied by 2 will be 4. 4 multiplied by 22 will be your 88 into R is equivalent to 88. So we can say R will be 88 divided by 88, that is 1. So value of R is your 1 centimeter. And diameter is asked, so diameter will be 2 times of your radius, that is 2 multiplied by 1. 2 centimeter will be the diameter of the base of the cylinder. Now we are taking question number 8 of exercise 13.2 only. In a hot water heating system, there is a cylindrical pipe of length 28 meter. This is how the pipe will look like. Here length is given to us as 28 meter. That means it is basically height of the cylinder if we will keep it upside down. And diameter is 5 centimeter. It is in meter. 28 is meter and 5 is your centimeter. So find the total radiating surface in the system. What will be the total radiating surface in the system that we need to find? See, the total radiating surface will be this only. This will be the radiating surface. From here and here, it is not going to radiate because water is going to pass through it. Water will be passing through it. From here, the water will pass and the radiating surface will be this surface, and this surface means curved surface. Curved surface will be the radiating surface. So we need to find basically the curved surface area. So curved surface area is your 2 pi r h. Over here, this length is the height of the cylinder. So h will be your 28 meter. So either we will be converting this 28 meter into your centimeter, or we will be converting this d into your centimeter. This is in centimeter, so we have to either convert this in meter or we have to convert this in centimeter. So we are converting h, which is 28 meter. So it could even be written as 2800 centimeter. We have converted this meter into centimeter because units we want in the same. Units of d, units of h, everything should be in the same unit. That's the reason we have converted it. So h is your 2800 centimeter. Diameter over here is your 5 centimeter, and we know that the radius is half of your diameter. So it will be your 5 by 2 centimeter. So now if we will be keeping all these value over here, it will be 2 multiplied by 22 by 7. R is your 5 by 2 and h is your 2800. 2 and 2 cancelled. 7 4 is 28. So it will be 22 multiplied by 5 4 is 20. This much. So 244,000. This much of centimeter square will be the radiating surface. And if we want to convert this into meter square, then what we will be doing is we will be dividing it by this much. So this will become 3 zeros cancelled. It will be 4.4 meter square. We know that 1 meter is equivalent to 100 centimeter, and 1 meter square will be 100 multiplied by 100 centimeter square. So 1 meter square will be 10,000 centimeter square. So we have divided this by 10,000 for converting it into meter square. So this is how we can solve the question using the formula. Till now we have studied about the shapes which we are getting by keeping the identical figures one over the other. Like we are getting cylinder by keeping the identical or the congruent circles one over the other. These type of solids are known as your prism. Now we will be learning about some different types of shapes, that is your pyramids. Now if we are going to take a right angle triangle, say we are taking a right angle triangle, this is a right angle triangle ABC. If on its one of the perpendicular side, if we are going to keep one of the string and we are going to rotate it, the shape which we will be getting will be a cone. We have seen the ice cream cones, we have seen the birthday caps. So all these are your conical in shape. So we will be learning about your cone, which looks like this is a shape of a cone whose base is your circular and this is your curved face. This is A, B, C. Suppose from here we have drawn a perpendicular, and suppose this point is your O. So OC will be the radius of the base, that is base is your circular. So OC will be the radius of base, circular base. AO is height. AO is height of the cone, and AC is known as the slant height of the cone. AC, which is denoted by L, it is your slant height of cone, and H, which is your OA, is denoted by H, which is height of the cone. Over here we can see that OC is perpendicular to your OA. That means AOC will be your 90 degree. This angle will be your 90 degree. So we can apply Pythagoras theorem in the triangle AOC, and in this triangle AC will be the hypotenuse. So L square, that is slant height square, will be your H square plus R square. So value of L will be root of H square plus R square. So slant height we can get by taking the square root of H square plus your R square. Over here we can see that this is a cone whose base is circular. If we are keeping, if this is at 90 degree, this cone is at 90 degree from the base, then we say it to be a right circular cone. And if it is not at right 90 degree, if it is inclined, this OA is inclined, then it will not be a right circular cone. Similarly, if the base is not circular, in that case even we will not say it to be a right circular cone. So in this chapter we will be learning about right circular cone only, where these will be at 90 degree. So L over here is the slant height, R is the radius of the base which is circular, and H is the height of the cone. So the curved surface area, over here we can see two faces are there. One is your curved surface, one is your curved face is there, this portion. This is your curved face, and the bottommost will, the base is your flat face. It is having two faces. One, it is your flat face which is circular, the bottommost, and one is your curved face, upper one. This is the curved face and this is your bottommost face which is circular, is your flat face. So two faces it is having. So what will be the curved surface area? Curved surface area of cone is given by pi r L, where L is the slant height. If height of the cone is given and radius of the base of the circle is given, then we can find the slant height. So slant height will be given by root of H square plus R square, because your radius and your height H is perpendicular to each other. They are right circular cone. So it will be, L will be given by root of H square plus R square. So curved surface area of the cone is given by pi r L. R is the radius and L is your slant height. Pi is the constant whose value we will be taking as 22/7 or 3.14 as per given in the question. And the bottommost face, the flat face, is your circular. So it will be, area will be your pi r square. So total surface area will be curved surface area plus area of the base, that is pi r square. So pi r could be taken common. It will be your r plus L. This will be the total surface area of the cone, and this will be the curved surface area of the cone. Using these formulas we can solve the questions. Now let's see some of the questions from your exercise 13.3. Question number 1. Diameter of the base of a cone. Diameter is given. It is given to us as 10.5 centimeter. And the slant height L is given. Slant height is given to us as 10 centimeter. Find its curved surface area. We know that the curved surface area of a cone is given by pi r L. Value of pi is 22/7. R, diameter is given to us as 10.5. So radius will be diameter divided by 2. So it will be 10.5 divided by 2, and L is given to us as 10. If we will remove this decimal, 10 will come in the denominator. So this 10 and this 10 is going to cancel. 2, 11 times 22. 7 1 is 7, and 7 5 is 35. So remaining is your 11 multiplied by 15. And if we are going to multiply, 11 5 is 55, 11 5, 165 centimeter square will be the curved surface area of the given cone. This is how, using the formula, we can find it out. Now let's see question number 6. The slant height and base diameter of a conical tomb are 25 meter. So slant height is 25 meter, and base diameter is given to us as 14 meter respectively. Find the cost of whitewashing its curved surface at the rate of rupees 210 per 100 meter square. This is the rate we have to get it whitewashed, the curved surface area. Obviously, bottommost, the base is not going to be whitewashed. Curved surface area will be whitewashed. So the area which is to be whitewashed is your curved surface area, that is given by your 2 pi RH. Sorry, it is pi RL. It is for your cylinder. For your cone, it is your pi RL. So pi RL will be your 22 by 7 multiplied by R is your 14 by 2, because diameter is 14 meter, so radius will be half of it, that is 7 meter. This is your R, L is your 25. So 2, 7 times 7 cancelled, so it will be 4, 5 is 550 meter square will be the curved surface area. Now the rate is your rupees 210 for 100 meter square. So for 100 meter square, we are paying rupees 210. So for 1 meter square, how much is to be paid? 210 divided by 100. But the area which is to be whitewashed is your 550 meter square. So for 550 meter square, how much we need to pay? 210 divided by 100 multiplied by your 550. So 2 zeros cancelled. It is your 21 multiplied by 55. So 55 multiplied by 21. 5 2s are 10, 5 2s are 10, so it is 1155. So rupees 1155 is to be paid for whitewashing 550 meter square of area at the rate of rupees 210 per 100 meter square. So accordingly, you have to decide whatsoever is given to you in the question, that which area is required, what all dimensions are given to us. Accordingly, we will be solving the questions. Now let's understand what is a sphere and what is the formula for finding area of a sphere. The most common example of a sphere is a ball. We all have seen it, that it is only having a curved surface. It is not having any of the flat surface. That's the reason we need not to find the curved surface area separately and your total surface area separately for the sphere. It is same in the case of your sphere. So what a sphere is? As we were saying in the case of circle, that if in a plane we are going to take all the points which are at equal distance from a fixed point, then the figure which we are getting is your circle. Similarly, your sphere is a three-dimensional figure. So if in the space we are going to take all the points which are at equal distance from the fixed point, then the collection of all these points is known as your sphere. It is three-dimensional. That's the reason in the space whatsoever the points are at fixed distance from the fixed point is your sphere. Here the fixed point is the center of the sphere and the fixed distance is your radius of the sphere. So if we are going to see the surface area of a sphere, so surface area of a sphere is given by surface area of a sphere is given by 4 pi r square. This is the surface area of a sphere. Now if we are going to cut this sphere from the center, that means we are going to divide exactly it into two halves, then we will be getting your hemisphere. Hemisphere means half of it. So this hemisphere will be having your two faces. One will be your curved surface and another will be your flat surface even we will be having. From where we have cut, it will be your circular face. So in the case of hemisphere, if we are talking about a hemisphere, then the curved surface area will be half of your surface area of the sphere, that will be your 2 pi r square. And the base, which is your circular, that area of that will be your pi r square. So we can say total surface area for the hemisphere will be your 2 pi r square plus your pi r square, that is 3 pi r square. This will be the total surface area of the hemisphere and this will be the curved surface area of the hemisphere. Because hemisphere is having both the faces, one curved surface it is having and the one flat surface is even having. But in the case of a sphere, we were having only one curved surface. That's the reason the surface area for a sphere was your 4 pi r square, and for the hemisphere, the curved surface area will be half of the curved surface area of your sphere, that will be 2 pi r square. But because bottommost surface even it is having, which is circular, area of that will be your pi r square. So total surface area of the hemisphere will be your 2 pi r square plus pi r square, that is your 3 pi r square. Now how using these we can solve the questions? Let's see. Let's take questions from your exercise 13.4. Question number 4 I am considering. Here R is the radius of the sphere. The radius of a spherical balloon increases from 7 centimeter to 14 centimeter. Question number 4 it is. Initially the radius was your 7 centimeter. Then it changed to 14 centimeter. I have represented this by R dash. Initially it was R, that is 7 centimeter. Then it changed to R dash, that is 14 centimeter. As air is being pumped into it, find the ratio of the surface areas of the balloon in the two cases. So we are assuming that initially surface area was S. When the radius was R, the surface area was S, and then when the radius was R dash, the surface area was S dash. We have to find the ratio of SS and S dash. This is required. So what surface area of a sphere is? We have just now seen that the surface area of a sphere is your 4 pi R square. So S will be your 4 pi R square. This will be your value of S, surface area with respect to your radius 7 centimeter. And what the value of S dash will be? It will be 4 pi R. Over here R is your 14 square. This will be the surface area when your radius is your 14 centimeter. Now we want as ratio of S and S dash. So S over S dash will be 4 pi. We can write it as 7 multiplied by 7. And over here in the denominator S dash 4 pi into 14 into 14. So 4 cancelled, pi cancelled, 7 2 times 14, 7 2 times 14. So ratio of S and S dash will be 1 upon 4, or we can say it will be 1:4 will be the ratio of the surface area when your radius has changed from 7 to 14. Now let's see another question, that is question number 8. A hemispherical bowl is made of steel, that is your 0.25 centimeter thick. Thickness is given to us as 0.25 centimeter. The inner radius of the bowl is given to us as 5 centimeter. Find the outer curved surface area of the bowl. Only curved surface area is required, right? So curved surface area, it is a hemisphere given to us. So for the hemisphere, the curved surface area is given by your 2 pi R square. Now the outer curved surface area is asked. What is asked is your outer curved surface area is required. Now see over here, inner radius is given to us and thickness is given to us as 0.25. So if we will be adding this thickness in your inner radius, we will be getting your outer radius. For getting the outer radius, we need to add your inner radius and your thickness. So outer radius will be your 5 plus 0.25. That is your 5.25 centimeter will be your outer radius. Now we want the outer curved surface area. So curved surface area for the hemisphere, we know it is your 2 pi R square. So it will be 2 multiplied by 22 by 7. R is your 5.25. 5.25 into 5.25. If we are going to multiply all this, your value will be 1212.75 divided by 7. That will be 173.25 centimeter square. So this will be the curved surface area of your hemisphere. So this is how using the formulas we can solve the questions. Till now we have learned that how to find the surface area of various solid figures like cuboid, cube, cylinder, cone, your sphere. Now we will be learning how to find the volume of all these solid figures. So first of all, let's understand what volume is. If we are talking about any of the solid figure or any of the solid object, then the space occupied by that particular object is known as your volume. And if that object is empty, then we are going to fill any of the substance inside it. The volume of the substance which can be filled inside that object will be known as your capacity of the container or capacity of that particular object. So now let's understand how to find the object of these various solid figures. First of all, talking about cuboid. Just now we have learned what cuboid is. Cuboid looks like this, which is having your 6 faces, and all the 6 faces are rectangular. If its length is L, width is B, and height is your H. So base will be your, this will be the base of this cuboid, and the area of this base will be your L into H, because it is having 2 dimensions, that is L and B. So for this base the area will be your L into B. If we are going to keep these rectangles, these same rectangles one over the other up to H height, then we are getting a cuboid. So volume of the cuboid will be your base area multiplied by its height. Volume will be base area multiplied by height. So base area will be your L into B and height is your H. So volume of the cuboid is given by your L into B into H. Over here we know, because we are using all the 3 dimension in multiplication, so its unit will be cubic units. If these dimensions are given in centimeter, so your volume will be your cubic centimeter. If these are given in your meters, then it will be your cubic meters. So volumes are always having units in your cubic units it will be having. Now let's see how to solve questions based on this concept. Let's take in questions from your exercise 13.5. Exercise 13.5. A matchbox measures 4 centimeter. L is given to you as question number 1. It is L is given to us as 4 centimeter. Width is given to us as 2.5 centimeter. And your height is given as 1.5 centimeter. What will be the volume of the packet containing 12 such boxes? Boxes are your 12 boxes are there. So what will be the volume of one box? Volume of one box will be one box, because it is cuboidal in shape. L, B, H all are separate. So it will be L into B into H. That will be given by 4 multiplied by 2.5 multiplied by 1.5. So 4 multiplied by 2.5 will be your 10. 10 multiplied by 1.5, that will be your 15 centimeter cube. It will be the volume of one box. Now we want volume of 12 boxes. So volume of 12 boxes will be, volume of 12 boxes will be 15 multiplied by 12, that is 180 centimeter cube. This will be the volume of your 12 boxes. Now this is the case when we are talking about cuboid, when your L, B, H are separate. But when your L, B, H are same, then it becomes your cube. We have already learned about it. Cube is having the equal L, B and H. If this is your A, L is your A, width is even A and height will even be A. So similarly, as we found the volume of cuboid, similarly we can say that the volume of cube will be, volume of cube is given by area, base area multiplied by its height. We know that in the case of a cube, the base is your square with side A. So area will be, base area will be your A square, and height is even A, so multiplied by A. So volume of a cube will given by your A cube, or we can say if we are taking the cube of the side, then we will be getting volume of your cube. This is the formula for finding volume of a cube. Now let's take question number 8 of exercise 13.5. Question number 8. A solid cube of 12 centimeter. Cube is, side of the cube is your 12 centimeter. 12 centimeter is cut into 8 cubes of equal volume. We are dividing into 8 cubes of equal volume. What will be the side of the new cube? Also find the ratio between their surface areas. Now see over here, initially the side of the cube was your 12 centimeter. It has been cut into 8 cubes which is having your equal volume. Now we are assuming that the side of smaller cube is equivalent to your x centimeter. Now volume of initial cube will be your A cube, that is side cube. So initial volume will be your 12 multiplied by 12 multiplied by 12. This much of centimeter cube was the initial volume of the cube. Now the new cube is having the side as your x. So volume of smaller cube is given by your x cube, because side is your x, so volume of the smaller cube will be your x cube, but it is having your 8 such cubes, so volume of 8 smaller cubes will be 8 multiplied by your x cube. And because this cube is melted into 8 such cubes, so volume of both the cubes will be equal. So we can equate both the cubes. This is the initial cube and this is the next condition after melting. So these two volumes will be equal. So we can say 12 multiplied by 12 multiplied by 12 is your 8x cube. If we are going to divide it, divided by 8 will be your x cube. 2 2s are 4, 2 6, 2 4 is 2 6, 2 6. So we can say 6 cube is your x cube, or the new side of cube will be your 6 centimeter. For the new cube, the side will be your 6 centimeter. Initially it was 12 centimeter. Now it is melted into 8 cubes of smaller dimension. So for the 8 cubes, your side will be your 6 centimeter. Now what is asked? Also find the ratio between their surface areas. So we know the surface area of cube is given by 6a square. 6 multiplied by side square is the total surface area of cube. So for the initial condition, when your side was 12, so initially surface area was 6 multiplied by side was your 12, this much of centimeter square. Later the surface area will be 6 multiplied by your side square, and new side was your 6, so it will be 6 multiplied by 6 multiplied by 6 centimeter square. Now we want the ratio of these two. So if initial surface area was S and later it was S dash, so S over S dash will be 6 multiplied by 12 multiplied by 12. This was initial surface area, and later the surface area was 6 multiplied by 6 multiplied by 6. 6 2s are 12, 6 2s are 12. So it is 4 upon 1, or we can say the ratio is your 4:1. This is the ratio between their surface area. Initially the side was 12 centimeter. Later it is melted into 8 cubes. So we found what will be the new side of your cube. Because this is melted into 8 such cubes, so volume of this will be equivalent to volume of this. So we have equated the volume. We got the new side of the cube. And once we are having the side, initially the side was 12, later it changed to your 6 centimeter. Then surface areas, formula for finding surface area is your 6a square. Then we have compared it, so value will be your 4:1. So this is how, using these formulas, we can solve these type of questions. Just now we have seen that the volume of the cube and cuboid we can get by multiplying the area of its base by its height. If we will multiply the base by its height, we can get the volume of your cube also and cuboid also. And we know that they are prism. That means they are the figures which we are getting by keeping the congruent figures one over the others. When we are keeping the congruent rectangles one over the other, we are getting cuboid. Similarly, when we are keeping the congruent circles one over the other, we are getting cylinder. That means for cylinder also, if we will be multiplying the area of the base by its height, we will be getting its volume. So let's see the volume of a cylinder. For cylinder, the base is your circle. The base is your circular. This is the base which is circular. The radius of the base is your r. And this is the height h of your cylinder. So if this is the height of the cylinder and this is the radius of the cylinder, so we know that for a circle, the area is your pi r square. That means area of the base will be your pi r square. And the height is over here is your h. So if we are going to multiply it by h, that means we are going to multiply the base area by its height. It will give us your volume. So volume will be, base area is your pi r square, height is your h. So volume of the cylinder will be given by your pi square h will be the volume of the cylinder. Now how we can solve using this formula some of the questions, let's understand it. Take your exercise 13.6 we'll be taking. Exercise 13.6, question number 1 we are considering. We are taking question number 1. The question number 1 says the circumference of a base of a cylindrical vessel is 132 centimeter. The circumference is given to us as, that means circumference of a circle is your 2 pi r, because base of a cylinder is your circle, and the circumference of the base of a cylindrical vessel is given to us as your 132 centimeter. And its height is given to us as 25 centimeter. Height is 25 centimeter. How many liters of water can it hold if 1000 centimeter cube is equivalent to your 1 liter? So what is the capacity or what is the volume of your cylindrical vessel? Now see over here, the circumference of the circle, that means circumference of the base is given to us as your 132. We know that the circumference is given by your 2 pi r. That means if we are going to keep its values, 2 multiplied by pi is your 22 by 7, r we have to find it out. It is equivalent to your 132. From here we can get the value of r, that means radius of the base of the circle. Over here it could be written as 44 upon 7 multiplied by r is your 132. Or we can say r will be 132, this 7 is in the division, will go over here in multiplication, and this 44 will go in division. So if we are going to multiply, if we are going to divide it 3 times, 4 3s are 12, 4 3s are 132, 44 into 3 will be our 132. So we can say radius will be 21, 3 7 is 21, and the unit is your centimeter. So radius of this cylindrical base, it will be your 21 centimeter. Now we have to find its volume, and now we know that the volume of the cylinder is your pi r square h. So volume will be given by pi r square h. So if we are going to keep the values, pi is your 22 by 7, r is your 21 multiplied by 21 because it is r square, and h is your 25. If we will be multiplying it, 7 3s are 21. So it will be 22 into 3 will be a 66 multiplied by 21 into 25. If we will multiply all these numbers, it will be your 34,650, and the unit is your centimeter, so it will be your cubic centimeter. Now we have to convert this into liters, and the relation is given to us as 1000 centimeter cube will be your 1 liter. So for converting it into liters, we will be dividing it into by your 1000. So if we will divide it by 1000, it will become your convert into liters. So it will be 34.65 liters. This is the capacity of your cylindrical vessel. This is how we can find it out. Now let's see question number 8. Question number 8 of this exercise. A patient in a hospital is given soup daily in a cylindrical bowl of diameter 7 centimeter. It is a cylindrical bowl and diameter is given to us as 7 centimeter. If the bowl is filled with soup to a height of 4 centimeter. So whatsoever is the height of the cylindrical bowl, it doesn't make a difference because soup is filled till your 4 centimeter. So height will be your 4 centimeter. How much soup the hospital has to prepare daily to serve 250 patients? Number of patients is your 250 patients. Now for one patient, how much soup is required? It will be equivalent to the volume of your cylindrical bowl. So volume will be, volume of cylinder is given by your pi r square h. So diameter is 7 centimeter. So radius will be half of the diameter, that is your 7 by 2 centimeter. So you will be keeping all these values over here. It will be 22 by 7. R is your 7 by 2 multiplied by 7 by 2 because it is R square into H. H is your 4 centimeter. So 2 times 4, 2 and 2 cancel. This 7 and this 7 cancelled. So it will be 7 2s are 14, 7 2s 14, 154 centimeter cube. This will be the volume of your one bowl, cylindrical bowl. Now it is for one patient only, but here there are 250 patients are there. So for one patient, your soup required is your 154 centimeter cube. So for 250 patients, soups required will be 154 multiplied by your 250. And if we will be multiplying it, it will be your 38500 centimeter cube. This much of soup will be required for 250 patients. Now this is in centimeter cube. If we want to convert it into liter, what we need to do is we need to divide it by 1000. For converting centimeter cube into liter, we need to divide it by 1000. So it could even be written as divided by 1000, this much of liter. So 2 zeros cancelled and it will be 38.5 liter of soup will be required. So this is how we can solve the questions using the formula. Now let's understand what is the volume of a right circular cone. We all know that the cone looks like this, where the base is your circular with the radius r. This is the height of the cone and this L is your slant height of the cone. So if we are going to take an empty cone and an empty cylinder whose radius are same, the base radius are same for the cone also and for the cylinder also, and if their height is even same, that means height of the cone is equivalent to the height of the cylinder. That means we have taken your cone and one cylinder like this. The radius for both the cone and the cylinder is same, both is r, and if their height is even same, if this is h, this is even h, in that case we can see that 3 times of the volume of your cone will be equivalent to your volume of the cylinder, or we can say that volume of the cone is 1/3 of the volume of the cylinder. If we are going to fill this cone 3 times and we empty the same thing in this cylinder, then in 3 times it is going to fill completely. That means volume of the cylinder is 3 times of your volume of the cone, or we can say volume of the cone is 1/3 of the volume of the cylinder. So we know that the volume of the cylinder is given by your pi r square h. So volume of the cone will be 1/3 of the volume of the cylinder. Volume of the cone will be 1/3 pi r square h. Now let's see how we can solve the questions using the formula. So we are taking exercise your 13.7. Let's solve some of the questions from exercise 13.7. We are doing question number 3. Question number 3 is the height of a cone is 15 centimeter. Height means h is given to us as 15 centimeter. If its volume is 1570 centimeter cube, volume is 1570 centimeter cube is the volume. Find the radius of the base. We have to take pi is equivalent to 3.14. It is mentioned that value of pi we have to take as your 3.14. We have to find the radius of the base. That means we have to find the value of r. We know that the volume of a cone is given by 1/3 pi r square h. Just keep the values over here. Value of v is given to us as 1570. It is equivalent to 1/3. Pi we have to take as 3.14. We have to find the value of r, so we will be keeping it r square as it is, and value of h is given to us as 15. Now if we will be solving it further, 3, 5 is 15. So 1570, it is equivalent to, if we will multiply 3.14 and 5, 5 4 is 20, 2 carry over, 5 1 5 6 7, 5 3s are 15. So it will be 15.70 multiplied by your r square. So what the value of r square will be? it will be 1570 divided by 15.70. If I'll be removing the decimal, 100 will come in the numerator and 1570 cancelled. So the value of r square is your 100 and value of r will be square root of 100, or we can say value of r is your 10 centimeter. We will be ignoring the negative 10 because value of r will be plus minus 10. So radius cannot be negative. So we will be taking value of r radius as equivalent to your 10 centimeter. So this is how using the formula we can solve the questions. Now let's take one more question, that is question number 9 from the same exercise, your 13.7. A heap of wheat is in the form of a cone whose diameter is 10.5 meter. Diameter is 10.5 meter and the height is 3 meter. Height is given to us as 3 meter. Find its volume. The heap is to be covered by canvas to protect it from rain. Find the area of the canvas required. That means we have to find its curved surface area also, because canvas is going to cover only the curved surface only, bottommost surface it is not going to cover. So curved surface area is also required and your volume is even required to us. Now see over here, diameter is given to us as 10.5 meter. So radius will be diameter divided by 2, that is 10.5 divided by 2 meter. This is the radius. First of all, we have to find the volume. So volume will be 1 upon 3 pi r square h. So we will be keeping all the values. 1 upon 3. Pi will be your 22 by 7. R is your 10.5 by 2. Again multiply by 10.5 by 2, r square it was, and h is your 3. So if I'll be removing this decimal, 1 0 will come in the denominator. If I'll be removing this decimal, 1 more 0 will come in the denominator. Now just cancel it. 3 cancelled. Then 2 11 times cancelled. 7 1 is 7. 7 5 is 15. So what is remaining is 11 over here. Then 15. Then 105. And in the denominator it is your 200. If we are going to solve this part, it will be equivalent to your 86.625 meter cube. This will be the volume of the cone. Now we want the curved surface area of the cone, and we know that the curved surface area of a cone is given by your pi r L, where L is your slant height. Over here we are having your h, we are having the r even. So how to find the slant height? We have discussed earlier that this is your right angle triangle. If this is your A, this is your O, and this is your B. So AOB is a right angle triangle. So over here we can apply the Pythagoras theorem. So according to the Pythagoras theorem, L square, that is hypotenuse square, will be your R square plus H square, or we can say L, slant height, will be under root of R square plus H square. So first of all we will be finding the value of L. L will be under root R square plus H square. So keep the values. H is your 3 and R is your 10.5 by 2 whole square. If we will be solving it, the square root will come as your 6.05. 6.05 will be the value of your L and it will be in your meters. This is your slant height. We will be solving the square of 3 will be your 9, and over here 10.5 over 2. So we can remove the decimal. It will come in the 0 will come in the denominator, and we will be solving it. We will be squaring it and then taking the square root. Then its value will be your 6.05 meter. This is your value of your slant height. We want your curved surface area. So curved surface area is your pi r L. So pi is your 22 by 7. R is your 10.5 by 2 and L is your 6.05. If you will remove this decimal, 1 0 will come in the denominator. If you will remove this decimal, 100 will come in the denominator. So if we will be solving it further, it will be 7, 1 15 it is, 2 10 times, 2 11 times. So it will be 1000 in the denominator, and if we will be solving it, we will be getting 99.825 meters square. It is your curved surface area it is. So unit will be your meter square. Whensoever it is your volume, unit will be in cubic units, and whenever it is your area, it will be in square units. So using the formulas, we can find the area, volume of your all the solid figures. Now let's understand what is the formula for finding volume of a sphere. We know that the volume of the sphere is given by 4 upon 3 pi r cube. This is the formula for finding volume of a sphere, where r is radius of the sphere. And if we are going to divide this sphere into two equal halves, that means we are going to convert it into hemisphere, then the volume of the hemisphere will be half of the volume of the sphere, that will be your 2 upon 3 pi r cube. So volume of hemisphere will be 2 upon 3 pi r cube. These are the formulas for finding volume of a sphere and volume of your hemisphere. Now let's see how using these formulas we can solve questions. Now let's see your exercise 13.8. Say question number 3. Question number 3 says the diameter of a metallic ball is 4.2 centimeter. Diameter is given to us as 4.2 centimeter. What is the mass of the ball if the density of the metal is given to us as 8.9 gram per centimeter cube? We have to find mass of the metallic ball. Now see, density is given to us, diameter is given, that means we can find the radius also. Radius will be diameter divided by 2, that is your 4.2 divided by 2, or we can say 2.1 centimeter will be the radius of the metallic ball. Now density is given and we have to find the mass. We know that the formula for finding mass is your volume multiplied by density. If we are going to multiply the volume by its density, we will be getting your mass of the metallic ball. So what we need to find is, we have to find the volume of the metallic ball. We are already having the density of the metal, and once we'll be multiplying these two, we will be getting mass of the metallic ball. So the volume of a sphere, just now we have seen that volume of a sphere is given by 4 upon 3 pi r cube. So we'll be keeping the values 4 upon 3. Pi is your 22 by 7. R is your 2.1. So 2.1 multiplied by 2.1 multiplied by 2.1, because it is r cube. So if we will be removing the decimal, 10 will come in the denominator. Now 3, 7 is 21. 7, 7 cancelled. So remaining will be 4 into 22 will be 88. Multiplied by 21 multiplied by 21 divided by 1000. So if we will be solving it, we will be getting 38.81 centimeter cube. This will be the volume of the metallic ball. And now we have to find the mass of the metallic ball. So mass will be volume multiplied by density. Volume is, just now we got it, it is your 38.81, and density is given to us as your 8.9. If we will be multiplying these two, we will be getting 345.39 grams. So mass of the metallic ball will be 345.39 grams, because density was in grams per centimeter cube. So your mass will be in grams, that will be 345.39. So this is how, using the formula, we can find the mass. Now let's see another question, that is question number 9. 27 solid iron spheres, each of radius r. So 27 iron spheres we have taken, radius is r, and your surface area is s. So these iron spheres are melted to form a sphere with surface area s dash. So new sphere, surface area of the new sphere is your s dash. We have to find the radius r dash of the new sphere, radius r dash of the new sphere, and we have to find ratio of s and s dash. This we need to find it out. So let's see over here what is said, that there are 27 iron spheres are there, and the radius of the iron sphere is r and surface area is s. These 27 iron spheres are melted, and we are getting a new iron sphere whose surface area is your s dash. So what will be its radius? So whenever we are melting any of the figure, any of the solid, if we are melting and converting it into another solid, then their volumes are equal. Whenever it is melted and converted or recasted into some other shape, in that case their volumes are equal. So volume of 27 spheres will be equivalent to volume of the one sphere whose radius is your r dash. So first of all, we are finding the volume of the sphere with radius r. Volume of sphere with radius r. It will be 4 upon 3 pi r cube. But now there were 27 such spheres were there. So volume of 27 spheres will be 27 multiplied by 4 upon 3 pi r cube. This is the volume of 27 iron spheres. Now it is melted and converted into a sphere whose radius was r dash. So the volume of the sphere, volume of a sphere with radius r dash, it will be 4 upon 3 pi r dash cube. Now this volume will be equivalent to this volume because this is melted to convert into this. So both their volumes will be equal. So we will equate it. 27 into 4 upon 3 into pi into r cube is 4 upon 3 into pi into r dash cube. 4 upon 3 cancelled, pi cancelled. This could be written as 27 could be written as 3 cube. Like this we can write. So this could be written as 3r whole cube is your r dash cube. That means r dash is your 3 times of your r. So new radius of the new sphere will be 3 times of the radius of the previous sphere. This is the first part solved. Now we have to find the ratio of their surface areas. So first of all, whose radius was your r? The surface area of that sphere will be, we know that the surface area of the sphere is given by your 4 pi r square. This is the surface area of the sphere. So surface area of the sphere with your r radius s will be 4 pi r square, and surface area of the sphere with radius r dash will be, that is your s dash, it will be 4 pi r dash square. And we know that the value of r dash is your 3 times of r, so it could be written as 4 pi 3 times of r square, or we can say, just let it be like this only. We have to find the ratio. So s over s dash, s is your 4 pi r square and s dash is your 4 pi 3 r square. 4 cancelled, pi cancelled, it will be your r square over 3r whole square will be your 9r square. 9r square, r square cancelled, the ratio will be your 1:9. This will be the ratio of your previous surface area and the new surface area of the spheres. So this is how, using the formulas, we can find the surface areas and volume of the solid shapes. Hope it is clear to you how to solve the questions, how we get the values of the surface areas and volumes of your cube, cuboid, cylinder, cone, spheres and all that. This is all from this chapter. Soon we'll be coming with the more videos of your 9th class curriculum. Thank you.